Today in class, I gave you an activity for how to derive the formula for calculating average atomic masses. It seemed like people understood that pretty well. I just wanted to go over a couple practice problems with you to make sure we were all good, and then we're going to do some more practice problems in class. So, most average atomic mass problems are going to give you this set of data. So let's say you have an element X. Element X has two isotopes, one with mass number 6, one with mass number 7, and different percent abundances for those isotopes. The question will also give you an atomic mass in AMU for that isotope. So you're probably wondering why the atomic mass in AMU for one atom is different from the mass number of the isotope. The reason for this is one, different isotopes, the actual atom has electrons in it, which are going to add to the mass. The other reason is because of something called nuclear binding energy, which we'll talk a little bit more about in class, but it's a little confusing, so we won't deal with it too much. But just know that there are other sources of mass in an atom besides just adding up the number of protons and neutrons. The number of protons and neutrons will give you the closest whole number, but there is a little bit of extra mass or a little bit less mass depending on what the atom is. So let's talk about the average atomic mass. Let's say we want to calculate the average atomic mass here. So the average atomic mass is equal to the percent abundance of a given isotope times the mass of that isotope plus the percent abundance of the other isotope times the mass of that isotope divided by 100. And that 100 has an infinite number of sig figs. So in this case, to find the average atomic mass, all you have to do is multiply the percent abundance of isotope X6 times the mass of isotope X6 to 4 sig figs. Then add the percent abundance of isotope 7, multiply by the mass of isotope 7 to 4 sig figs. So that's the protons, neutrons, electrons, and the nuclear binding energy, which we'll talk about what that is in class tomorrow. But then you just add those numbers up and then divide by 100%, and you get 6.939 AMU, and that's going to be your average atomic mass. So that should be pretty easy. Hopefully you all had a chance to do that kind of problem in class. We'll be doing more of that kind of problem tomorrow, but just wanted to give you another example. And of course, we always have to round to the correct number of sig figs. So here we have another example that is a bit more complicated. So in this question, the average atomic mass of chlorine is 35.453 AMU. So they give you the average atomic mass, and they're asking you to solve for the percent abundance of chlorine 35 and chlorine 37 if you're given the mass of each isotope to 4 sig figs. And notice that this time the mass of each isotope is slightly less than would be expected if we just added the number of protons and neutrons. And there's a reason for that. We will talk about that in class tomorrow. But let's just try and figure out how to solve this kind of problem. So the formula we're going to use is the average atomic mass is equal to percent abundance times the mass of each isotope divided by 100%. So let's just plug in the values we have and see where we are. So we have 35.453 is the average mass, and then plug in the isotopic masses, and we're left with two unknowns. Now, if I have one equation and two variables, I can't solve for one of the variables. So I'm going to need to do something else. So I have a percent abundance of 1 and the percent abundance of 2. So it turns out that if these are my only two isotopes of chlorine, and I know the percent abundance of 1, I can figure out the percent abundance of 2. So the percent abundance of 1 is just 100% minus the percent abundance of 2. So if I call my percent abundance of 1 X, I have 35.453 equals x times 34.97 plus, and then instead of percent abundance 2, I just have 100 minus x of 36.97, and then divide by 100%. And then do the algebra, I should get that x is equal to 75.85% chlorine 35, and then 100 minus x is 24.15% chlorine 37. So, I did not do the algebra purposefully. I would like each of you to attempt to do this problem and attempt to solve for x, and just make sure that you understand how I'm getting 75.85% chlorine 35 and 24.15% chlorine 37. Let me know if you get the correct answer. If you don't, if you have any questions, I'd be happy to answer them next class. I will see you next class.